Hello, good morning everyone. This is Santosh Kumar. Today I am presenting Financial Forecasting Frontier Distributed ML. So, this is the capstone project on banking data analytics with Hadoop, Hive, Apache Spark, Spark, Spark ML, and Spark Streaming. So, this is the introduction part of my project. So, banks generate enormous volumes of customer transaction and campaign data every day, and the value of that data depends entirely on how quickly and reliably it can be turned into decisions. This project builds a complete distributed data pipeline for a bank marketing dataset, that is bank.csv, covering the full journey a real banking analytics team would follow, storing data at scale, exploring it, predicting customer behavior and monitoring transactions as they arrive, and understanding how the underlying distributed engine parallelizes the work. The dataset used here comes from a Portuguese bank's direct marketing telemarketing campaign for term deposits and contains 4,521 customers across 17 attributes: account balance, existing loans and campaign contents details, call duration, number of contacts, previous outcome. The target field Y records whether the customer subscribed to a term deposit. Rather than analyzing this data with a single machine tool, the project deliberately uses a distributed computing stack. So first is Hadoop HDFS. The distributed file system banks use to store data too large for a machine. Second is Hive, a SQL layer over the distributed storage, simulated here via Spark SQL catalog, so the dataset can be queried like the data warehouse table. Third is Apache Spark, the distributed engine that performs exploratory analysis, transformation and aggregation in parallel across partitions. Spark ML, Spark's distributed machine learning library used to train models that predict which customers are likely to subscribe. Spark streaming, structured streaming. So this is used to simulate and process a live feed of banking transactions, the same mechanism a bank would use for real-time fraud detection and monitoring. So this notebook is built to run top to bottom in Google Colab with zero manual setup. So we have we have the file of bank.csv. Every cell have the checked to run cleanly, and every chart is generated live from the data. So we have run this code. First we have made the GitHub link for that. This is the GitHub link of my file. So after that we have made a uh, library imported. So first we import the matplotlib.pyplot as plt, import matplotlib package as package, import numpy as np. So we have plot the figure to make a image. We make an image for that. So this is the financial forecasting frontier distributed ML. This is the image for we have made by coding. After that we have installed the PySpark. PySpark installing pip install PySpark, and we have printed this PySpark version. After that we have set up the environment. We have initialized the local Spark session. All CPU cores available in the Colab VM to parallelize work, which is exactly mechanism for real multi-node cluster usage across machine instead of cores. So from pyspark.sql import Spark session. So we have made this code for PySpark. So this is the Spark version. We after running the code we have getted the PySpark version 3.5.1 and default parallelism is 2. After that we have load the banking dataset. Load bank.csv in this form, so data types are correct from this start. So this is the code for inserting this file. So we have choose this file bank.csv. After that it have the root a job, marital and education, default balance, housing loan, contact day, month, duration, campaign, per age, previous. So only showing top 5 rows. Total records are 4521 and total columns of in this CSV file are 17. So objective first is for that data storage and management, Hadoop and Hive for this project. Persist the dataset distributed of paraquet format in this is used for Spark SQL catalog and managed table. So this is the Colab notebook for that. We have printed firstly we have create database for that, and in Spark SQL we have query run of select job, round average balance and counter with group by job. So after running this code we have getted the output for this. So this is the output for this code. Data stated to content bank paraquet and the paraquet format. IDFS style distributed. Namespace table name is temporary. Banking customers false. So and job age are 30 to 59 and job unemployed and services management and blue collar job. So this is for the query run, and we have got it the balance and housing loan and contact if available, cellular or unknown, and day. Job job have many fields: retired, household management, entrepreneur, student, unknown, so self-employed, technician, admin. There are many types of job founded in this code. So yes or no customers with this PCT. No have 4000 value and yes have 521 values. So second objective is ADA, exploratory data analysis with Spark. So data quality check. Firstly we check this quality of data. Sorry. We have confirmed there are no missing values. Then review summary statistics for the numeric field. df.select app count, app.when column if is null. So we have run this code and got these values. Counted 4521 value, mean of that, and standard deviation, minimum and maximum. So this is the value for that. Second of this is target variable distribution. The target Y from deposit subscription is imbalanced. So this matters for how the model is evaluated later. So this is the code for that, and we got the values, and this is the chart for this. So number of the customers, if subscribed, there have only 521 value with brown color, and this is the 4000 in blue color. So this is the no value for subscription of the customers. So subscription rate and job and education. By job and education we have subscription got at the subscription rate. For that we have made this code and got the value. So by job, retired, student, unknown, management, household, this is the job type. Also blue collar. So term deposit subscription rate by job. So we have seen this, the retired and student have the most values with the subscription rate of 20 plus, and unknown have 15 to 20 value, and management have less than 15 values. Management, admin, self-employed, technician, unemployed, service entrepreneur and blue collar have the subscription rate has lowest values. Blue collar have the lowest values of subscription rate. So education, tertiary, secondary, unknown and primary with total values and subscribed value subscription rate packet for that. And next is cell duration, balance and correlation with subscription. So this is the code for that, and we have run the code and get the value. Correlation with age y flag, balance y flag, day y flag and duration campaign per day and previous. So this is the chart for that correlation of numeric feature with subscription y. So we have seen the duration have the maximum values and campaign has the negative values in red color. So subscription rate with the previous outcome, loans, marital status and contact type. So this is the value after running the code. After that, predictive modeling with Spark ML, feature engineering pipeline. So training rows has 3662 and testing rows has 859. To train and evaluate models, this is the model comparison, logistic regression versus random forest. So AUC, accuracy, F1 and precision. So this is the logistic regression have the blue color value and random forest has the orange color value. So this is the chart for this score. So feature importance of that, inspect with the injured features with the random forest railed on most. So feature index, and this is the importance. So top 10 random forest features importances. This is the 47 has the maximum importance of feature index assembler input, that has 0.30 values for 0.30 importance on that. And after that, next objective is real-time transaction analysis, Spark streaming. So this is the code, and streaming query started, so is active is true. Simulating live transaction feed, we have made the value of high risk and normal risk. So live risk monitoring flagged transaction per batch, this is the graph for that. So this is the chart for that transaction count and streaming batch. So high risk had the red values and normal have green values. So normal is maximum values with streaming batch. So window operation watermark order data is simulated transaction. Given the event time, we aggregate transaction count and the average balance in 10 second tumbling windows, attach a Spark knows how long it wait for late arriving data before finalizing Windows result instead of waiting for it. So this is the code for that, and we got the Windows streaming query started is active is true. So this is the Windows watermarking check, and we have made the trending curve also, transaction count and average balance over time. So this is the curve for that Windows start time and transaction count. Transaction count has the blue value and average balance have the orange value. This is going to 265 to 300, and then average balance go to 1530 or 20. Window start time, this is the value. And objective next is data parallelism. We have demonstrated how Spark distributes work across partitions and how repartitioning and caching affect parallel execution mechanism that Spark scale the banking sized dataset. So this is the default number of partition are 1. After repartition, this is the 8. So this is the partition at each stage. So we have got the 8 something value of this after this partition value. Conclusion and learning. So this is the we have this notebook implemented all 5 objectives of the capstone against the real bank.csv dataset. Storage and management, EDA with Spark, predictive modeling, real-time streaming, data parallelism. So this have the future improvement, class imbalance handling, class weighting or smooth, the hyperparameter tuning via cross validator, a genuine Kafka streaming source, and deployment on managed cluster, distributes EMR on YARN for elastic scaling. So thanks for watching.